Well, hi folks, this is Darren with My RV Works, and we're in Joyce, Washington today. It's like the middle of May and it's like 60 degrees, so it's kind of cold, but we're working on this refrigerator today. The customer states that it's working fine on electricity mode, but it's not working on gas mode. And so I've confirmed that by just coming in here and pushing the button, and let me bring you closer and show you. But when we put it, let me just do that now. So let's come over here and I'll show you what it's doing, but that's what we're working on. We're trying to get this refrigerator diagnosed and repaired on working on LP mode. Okay, so basically this refrigerator is a three-way. What that means is it can work on AC shore power, it can work on LP gas mode, or it could work on DC mode. I only want you to work it on DC mode if, like, this is a truck camper, okay? I only want you to work on DC mode when you're in a vehicle where you're driving and you have the benefit of that alternator. So when we turn this on, well, now it's not going to do anything for us. Okay, here we go. Okay, so it's in gas. And now I've done another video where we explain what this check light does and that relationship to the auto, the gas, and then resetting it, going in and out of the check mode. So what we'll find happening here is we've forced the refrigerator to be in gas mode by pushing the auto button. And after an interval of time, the check light will come on. Now, what you should hear right now is a ticking sound on the back of this refrigerator. Now, we're going to go around back and we're going to look at that. I do not hear the ticking sound. I do not hear anything. So after a moment, we're going to see the check light come on. There we go. Okay, so the check light came on. And in that other video, what that means is this refrigerator has tried the best it can to comply with your request to start on gas mode, and it was not able to detect the flame. And since it was not able to detect the flame, it's going to let you, human, know that I can't detect the flame. I'm going to turn on a check light, and I will never, ever, 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 ever try to light ever again as long as my check light's on. Now, to clear your check light, you cycle power, and then it's going to go back into gas mode, and it's going to repeat the cycle where the check light will come on. So we've done a video. We'll make a link to it down below and up above, a video on where I go into great detail on the check light. But you just saw what it did. So now what I want to do is we're going to go to the back side of this refrigerator where the control boards are located and see if we can't follow the trail and diagnose the thing. Maybe there's something wrong with this. This is called the eyebrow board or the upper control board. So maybe there's something wrong with the eyebrow board. Maybe there's something wrong with the control board. Maybe there's something wrong with the igniter. Maybe there's something wrong with the electrode. That's what we're going to follow the trail on. All right, so I'll move everybody in the back. Okay, so I've moved everybody to the back side. This is the control board here. And so let me get that off. And okay, so, okay. Oh, that was easy. Okay, and it's a Dinosaur Electronics, which tells me that someone has worked on this before, because the Dinosaur is a great board. It comes with a 3-year warranty. Big fan of them. I put a lot of them on myself. But the refrigerator doesn't come with this board, so I know that it's been worked on previously, just from that right there. Now let me grab my meter. I think one of the things that will be fun to do is to bring you guys in and show you the diagnostics mode from the eyebrow board. I could have done that from the inside, but I'm back here, so let's just see what we can do. So I'm in DC mode. Everybody see that? Okay. Now, I expect there to be voltage on this, and the reason why I expect there to be DC voltage here is because we were getting control signals inside. But let's just verify what we're dealing with. Okay, 13.3, so we're good there, okay? So therefore, I expect my fuse to be good, etc. Now, what I want to do is I'm going to run inside, and I am going to put this in DC mode. Okay, now let's do a little show and tell. Here's our solenoid that we're trying to engage. So I need to hit this with 12 volts. And the other thing I need to do is the igniter is this wire right down here. And let me take this cover off and we can peek in there. All right. So I'm going to take this cover off. And taking these off, here, let me get both hands available. You've got to overcome a little dimple sometimes in these covers, and what you're overcoming is this little lip right there. Okay, so there's one screw on the top, and if it's stuck, you got a dimple right there, but what you're really overcoming is this right here. But if you work with it, it'll snap off, okay? But it's just that one screw. So right in here, can you guys, yeah, this is the electrode, okay? We want that electrode to be about 1/8 of an inch above that burner head right there. And while we're at it, a lot of times that burner head might be clogged up with rust from the boiler. And so this whole problem could be that the burner is full of rust. And so it could be that, it could be the solenoid. Okay, and so what we need to do is we need to prove that 12 volts is engaging the solenoid. We need to prove that, and we need to prove that this is arcing, going tick, 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 and that's the spark pluggy sound that we were referencing on the inside. So we need to verify that we have LP, that our pressure is good. We need to verify that the solenoid is engaging, allowing propane through. We need to verify that our electrode is actually ticking and that it is a correct gap above the burner head. And then we also need to verify that the burner head is not full of rust. Now, the thing that the solenoid, so that's this side, that's going downstream. Going upstream, back behind this control board, you have on this refrigerator model, let me see if I can move this out of the way. Sometimes these lift up. Okay, there's another screw back here. This little white module back here is the igniter. Sometimes those will go bad. It's not as common because it's a sealed potted unit, but these white little, I've seen them in white, I've seen them in black. You also see these on stoves that have that igniter button where you don't have it. You got the stove that has a click thing, but there's some stoves where you push a button in and it's the same module, same part number. So sometimes these might go bad. So what we're going to be doing is this yellow wire coming out of our control board, we'll follow it around. It goes over to the solenoid, but it also daisy chains off the solenoid pin to feed this guy right here, this igniter. I'm not pointing to the green DSI, the lower control board. I'm pointing to this electrode module in the back, the DSI module. If that's bad, now how we know this is it's a go, no go. We're going to feed this 12 volts from the board. So when we put this refrigerator to gas, I expect there to be 12 volts on my yellow wire. Okay. And then I expect my solenoid to engage. I should hear a click. And then I expect the 12 volts to come into my white box here, this igniter. Sometimes they're black. I think I've even seen them in blue. And then coming out of this igniter, that's where I expect to see my ticky tick tick sound. And then once we have flame, the igniter will go into what's called rectification mode, which is at 1/8 of an inch gap. The gap above the burner is a function of the width of the electrode wire itself. And then it's going to read back a milliamp current. So there's a lot going on the gas side. Okay. So could it be the board? Now we know the board has 12 volts because we just checked that and it looks like it's a new board. But could the board be defective and not sitting 12 volts out on our yellow wire? Okay, maybe the thing is sitting 12 volts out on the yellow wire. Great. Is it our solenoid that could be defective, not allowing the gas to go through? Well, let's say that that's fine. It could be a ground because the other end of this electrode, the other end of this solenoid valve is a ground. So it's going to be grounded right here on the board. Could we have a floating neutral, a floating ground somewhere? We're going to look for that. Daisy chaining off of our solenoid. We come over here to our igniter. Now, some of your boards will have the igniter on the board itself, okay? But if you have the electrode, you will have an igniter. On this refrigerator, the igniter is separate. On some of your refrigerators, the igniter is integrated into the control board, the lower DSI board, DSI, direct spark ignition. So, circuit coming to here, and then we're going to give this white little box 12 volts, and out of that 12 volts is going to come our ticking sound, and then we should get ignition. So, what I want to do, and then towards the end, I will show you how to go inside on the upper eyebrow board and hold a couple buttons down and go into diagnostics mode where we can just force the issues. I could show you that, but I need to go look up. The way you control what mode you're in is by the 1, 2, 3, 4, 5 button, and I don't have that in my head. I'll make a tech card for that. And anyway, so we'll get into that towards the end of this. I'll show you that little trick, and then I'll go take a timeout, and I'll go look up what the modes are, and we'll go through that, and I'll show you that towards the end. But that's kind of a neat trick. So let me get set up with these tests we're going to perform, but I guess I wanted to just do an overview on some of the components involved that we're going to be looking at, and we need to prove things as we go. Are we getting 12 volts coming out of this? Reference to the white wire, which is ground.
Are we getting 12 volts to our solenoid? Is a solenoid engaging, letting gas go through? Is the white box receiving the 12 volts and sending out the current going to our electrode? Is electrode sparking? Tick, tick, tick. Is our burner head here full of rust? And even though maybe I'm ticking and maybe my solenoid opened, the LP can't go anywhere because it's fouled out. Now, from the inside, I was not hearing any ticking sound. Therefore, I did hear a clunk, but I wasn't out here to smell the gas. Normally, the other thing is this orifice right down here. This orifice, I believe this orifice, I get Norcold and Dometic confused. One of them has a man-made ruby in it. It's like a little pink colored ruby on the inside, and you take that off and you look at it and you clean it. Maybe everything's working great, but our orifice here is clogged. I have seen insects make a nest in there, and also you've taken the orifice off and we've seen like a charcoaly soot buildup inside of them. So all the different things that can go on with the gas side of a refrigerator, okay? So let me get some things ready to perform some tests, and we'll figure out, is it the board? Is it the wire? Is it a neutral? Is it the solenoid? Is it the electrode? Is it the electrode wire itself? Is it the orifice? All these different things. So let me get some tools ready to do a test. Be right back. So I had to put a jacket on. It's my mind is telling me it's the middle of May, but it is like, I don't even think it's 60 degrees today. It's cold. So I did put a jacket on. Okay, so let's begin the discovery. Now, one of the things I wanted to verify is that we have LP. Wouldn't it be crazy to diagnose the gas side of this refrigerator and have no LP? So I went inside and I verified that when I light my stove, the stove will in fact light. So we're good on that. That is not the same thing as the stove lighting isn't making it to this point right here, but if we don't detect anything, then we might tap into it right here and do an LP test on it right there. So I'm going to take my meter, put it in DC volts. So I'm on DC. Everybody see that? Maybe a glare. All right, hope that works. Okay. Now I've got these little pointy probes that I put on the ends of my meter. Okay. We've got a whole test lead set. I'll do a shameless commercial plug. If you go to our website, you'll go look at the tools that I make. And I don't make these, but we do buy them in bulk and we sell them along with other test lead type equipment. And I use those almost daily in my working on RVs. And there's so many different ways that they can assemble themselves. So one of the things that I had mentioned was if the board is working, we should get 12 volts coming out on the yellow reference to white wire. So yellow is going to be 12 volts plus, and white is going to be 12 volts minus. Okay, why do I know that? Well, because over here on my solenoid, you can see there's this hose in the way. Let me move that away. You'll see a white, which is ground, and the yellow. Okay, so we know in order for this solenoid to work, it needs 12 volts. Therefore, I'm going to get 12 volts plus on yellow and 12 volts minus on white. Okay, so what I'm going to do is I'm going to run inside. You guys watch this. I'm going to put this in record mode. So what record mode is going to do is basically, was there a glare? I've done videos and all of a sudden there's a terrible glare. Let me do it this way. That's even worse, isn't it? Hold on. Let me give you guys a good shot. I think that's better. Okay, I hope that's better. We'll just hope that that's better. If not, I'll tell you. So anyway, I've got min-max mode on. That way, if I miss something, I can see that it tried to peak. So right now I'm at 0, and we long press to turn min-max mode off. So I'm at 0, press it, I'm on. And so I'm going to go put this refrigerator in DC and gas mode, and we're going to see if I get 12 volts coming out on the white and yellow wire, which would feed our solenoid. So I'll be right back. Okay, I've got 11. Let me turn that off. Okay, so I'm reading my voltage coming out of the control board, so I can eliminate the control board as a problem. Next, I'm going to go over here. I am detecting some LP smell. So now what I want to do is, yep, I'm definitely detecting LP smell. So the valve's open. And okay, I've got 12.5 going into my igniter, but I'm not getting a ticking sound. But I've definitely got a strong ethyl mercaptan smell coming from my the valve, and it looks like he just turned himself. Oh, there, he's still there. So you know what? What we've just established by me turning it on gas and being out here with my meter and my little pointy probes is our green Dinosaur electronics board is good. I'm smelling LP, therefore our solenoid is good, and so I do not detect the orifice being clogged, but it still may be. It may be enough for us to smell it, but not enough for it to deliver. And I'm getting 12 volts coming in on our little white electrode. I'm sorry, the DSI board. Shoot, hold on. Too many words. This is the igniter, this white thing in the back. So I'm getting 12 volts going into the igniter, but nothing's coming out to my electrode. So at this point, I am highly suspicious that it's this igniter. So let's go grab a new one and hang it off to the side and move our wires over to it. If it turns out to be the problem, we'll go ahead and do it officially. But as of right now, if we are following the trail is dead-ended on our igniter module, okay? I have one in my service trailer, so I will go get one, and we'll see if that wasn't the whole problem all along. While we're at it, I'll still get, I like those little cans of office air. You can blow out these little burners. If it turns out that it's the igniter board, there's no reason to take this burner apart. It looks clean. You know, it's not all deformed or anything. But it's always good to just get those little cans of office air. I would not do the can of office air when this thing is trying to ignite because there's butane in those cans and you'll have a pretty impressive flame. So what I want to do now is go get another igniter and we'll just hang it off here and see if that doesn't fix our problem. Okay, went and grabbed the new igniter, so we'll go ahead and put this on, and that's what this igniter is. And if you look pretty closely, you'll see the plus and the minus. Forget the L. The L, nothing goes in the L, and then the igniter goes in this bottom pin. So the igniter goes in that little bottom pin right there. Forget the middle pin, and it's just plus and minus. If I give this thing 12 volts right now, on the minus on the top and plus on the bottom, this thing is going to start sparking on the bottom. It's really a dumb product. In other words, there's nothing. And then I got my sticker on the bottom, but it's potted, so they put this epoxy in it, so there's nothing. There's no user serviceable parts on it. So to do that, this is the same bit that I used to take that screw off. So we're going to just kind of put him in there. Your mileage may vary how you get to these things. That's why we've got all these little right-angled things to be beautiful. Okay. Get our screw. And we also carry magnetic little wands. All right, let's come out of there. I just need a little slack. What's holding it? All right, so I'm going to unplug that guy. There we go. Okay, so what I'm after here is that electrode wire. That's what I was after. And I needed to move the board to get to that. So we're going to plug that in there. And then we have yellow, like I said, goes to plus. And the black goes to minus. So like I said, it's going to be ugly, but we're going to just do like a, you might call a bench test. Okay, so it's just hanging in there, and we're going to plug this back in. Okay, so this is just a test. I am suspicious of this igniter. And so what I'm going to do right now, I'm just going to run inside. Oh, and you know what? I misspoke earlier. So on the Dometic boards, my experience has been when the check light comes on, it never, ever, 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 ever tries to start again. But this is a Dinosaur board. And what I have detected is the check light will come on and it'll wait an interval of time, and I haven't figured out how long, but it's going to try to ignite again. So earlier I said that it'll never, ever, 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 ever try to ignite again, but with this Dinosaur board, apparently it will try to reignite again. So that was, I would have never detected that, but I'm working on it, and I knew the check light had come on the inside, but then this thing started to ignite again. I'm like, tried to. So anyway, file that away. The Dinosaur boards apparently will try to reignite. So we're reconnected. Everybody's good. I got this thing just kind of hung in there, and I'm going to go turn it back on, and we're going to see if we get a tick, 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 and we'll see if we have happiness. So let's go see. What'd I miss? I just got back. I got my meter and follow the circuit. Oh, there we go. I just heard it. He's trying to. Okay, there we go. And we have ignition. All right. So I think we diagnosed this properly. It is this igniter board because, here, let me move you guys so you can see that. Can you guys see in there? So if you can, great. If not, but anyway, you have a flame in there. And the other thing you might see is that little orange electrode glowing, and this flame is being sustained. Let's say that we had an ignition, but the flame went out. Well, if we were able to get ignition, but that the flame then went out, that would say that the board is not able to detect the flame. And in this instance, it's not the board that's detecting the flame, it's this igniter that's detecting the flame. So that would be how that works. So what I get to do now is officially install that. So I'm happy. We diagnosed it properly. So it was this. Alrighty, so I'm kind of excited about that. So what I'm going to do is disconnect this, okay? And that basically just turned off the gas. Okay, the refrigerator is still trying to start. And what I can then do is officially install that. So that looks like a Phillips. There's my screw. Let's see if we can get this out. Or does it have a screw on the bottom too? It might have a screw on the bottom. Yes, it does. All right. Okay, another right angle. I'm going to save everybody a lot of time watching me get this bottom screw out. The next time you see me, the new one's going to be in and connected. And then what we'll do is what I promised, we're going to show you the diagnostics mode from the upper eyebrow board. So do some Hollywood magic. You do not need to watch me and waste your time fighting this little screw and putting a new screw in and reconnecting wires. So let's just save everybody the trouble on that. Okay, we're back where we began. I believe the customer will be happy. We've got the problem diagnosed. We got it fixed. I had mentioned that I was going to show you the diagnostics mode on these Dometic refrigerators, and I'll show you that now, and then we'll be done. So I don't use this very often. I don't know why, and I had to take a few minutes and go look up what 1, 2, 3, 4, 5 mean. But, and I haven't found this work on every single Dometic refrigerator I've tried with. What I do is the way I did it out there. I walk in, put it in a mode, go out there and check. What's really handy is if you have an old refrigerator, go ahead and keep the eyebrow board with you. This is for the RV techs, and just have it with you, and then you can just plug it directly in on the control board. You might need a variety of different control boards, but it makes it easy. You don't have to walk in and out. But to go into the diagnostics mode on a Dometic refrigerator, you're going to hold down. Now you're going to start with the whole eyebrow board being off. You're going to push down and hold the cold button, and you're going to push down and hold the on-off button. You're just going to keep doing that, and all of a sudden you're going to get a Christmas tree pattern here. Okay, hold on, we're not there yet. We're not there yet. Okay, there we go. We got a Christmas tree pattern. It's doing all kinds of things. Okay, and then you know it's done when the check light is blinking. Okay, so all we did to get to this is press and hold the cold button and press and hold the on-off button and just kind of wait, and then it's going to start doing this little pattern. Okay, so with the check light blinking, that's telling you that the refrigerator is in hold mode, and I've got my notes here. So now that we know how the check light's blinking, we're in diagnostics mode. Then you go to the different modes. Here, I'm just going to hold that up. There you go. And these are just my notes I scribbled down real fast. And so mode 1 means everything's turned off. Mode 2 would be your AC heating element is engaged. It's on, okay? And what you're going to want to do at that point is verify that you've got, at room temperature, you're going to want to check your ohms value, and you're going to check your current going through the heating element. Both. You need to do all that to verify it's good. So that's going to be mode 2. That should be AC heat. Mode 3 is going to be your gas mode. So at this point, we would hear the clicking, we would hear the sparking, and we have forced this refrigerator into LP heat mode, okay? Mode 4 here is going to be DC heat mode. So for those that have a 3-way refrigerator, in this instance, I have a 3-way refrigerator. Here is a cat. I believe that's Romeo, because he is a lover. He's a namesake. He's loving. So number 4 is a DC mode, and then number 5 is the spark only. So it's not going to engage the solenoid to allow fuel in. It's just going to check the spark. And so that's what we could have done originally when we were diagnosing this. I kind of go my way, you know, probing in and seeing it work. But this would have been a nice thing. So there you go. To get out of it, you just turn it on and off. But I think what I may do is we do tech cards. I've got a tech card out now for Aquahots, but this would be a candidate for RV tech cards. But anyway, there you go. Let's do that one more time. I'm going to turn it off. Okay, I'm going to go into diagnostics mode. Like I said, I don't use this mode very often. I can't keep the 1, 2, 3, 4, 5 in my head. It's easy enough to just know hold down cold and hold and press on off, and then just give it a minute. You know, be patient. It's going to turn itself on, and then keep holding. There you go. When you start getting these dancing lights all over the place, what it just did was it just checked all your light statuses to make sure that all your LEDs are illuminated. And when your check light comes on, all off. Number 2 is AC. Number 3 is gas. Number 4 is DC. Number 5 is spark only. Okay, so I hope that helps. And so we did this video. We came out here and didn't know what was wrong with it, and we just kind of followed the trail. I tried to sew in some of the thought processes that would go through my mind as I was diagnosing. Tried to sew in a little bit more about behind what the gas mode on these refrigerators, what things it could have been. So hope that added value to you as you're diagnosing your refrigerator, or just filing this away in case you need to know this on a rainy day. So if this was helpful, share it with your friends. Thumb up the channel. If you've not subscribed, consider subscribing. And I would like to invite you over to our Patreon site. We have a free membership there where you can kind of look over the fence and see what's going on. But we have a $5 tier, a $15 tier, a $25 tier where you can kind of get involved at the level that you're most comfortable with. We've got... we're always making videos over there that you may not find over here. So I'd like to invite you to check that out, even if it's at the free level, just to see if it's something that you are interested in. So, hey, this is Darren in Joyce, Washington, where Happy Campers Say My RV Works, and I hope that you found value in this. Thank you for your attention, and I'll see you on the next video. Bye.